Hello students, good afternoon. This is the first class with me in the crash course, and we will start by inverse trigonometric functions. And basically inverse trigonometric function, I think I'm audible, na? Can Meera and Upasana, can you hear me?
Yes, sir.
Yes, sir, you are audible.
Okay. We are going to do inverse trigonometric functions in this class. So since it is uh, not a non-crash course, it is a crash course. So we will not go into details, but we will revise important questions which have come recently, and we will do theory also in between. Like if something is being applied in a question, we will revise that theory, we will see the formula or something, and then we will use it to solve the question. So we will try to do this uh, chapter in this manner, and in the further chapters also we will mainly deal with questions and theory will get revised alongside. So if I talk about inverse trigonometric functions, uh, in this chapter there are formulas, many formulas, but basic concept should be clear, that there is a concept of principal value, and that principal value is for, if you remember, you have studied that for sine it is minus pi by 2 to pi by 2, for cos it is 0 to pi, for tan it is minus pi by 2 to pi by 2, then sec it is 0 to pi, cosec it is minus pi by 2 to pi by 2 except 0, and in also sec 0 to pi except pi by 2, and cot is 0 to pi. So this is the backbone of everything which we do in inverse trigonometric function. And of course, we should know the formula, and we should also know how they have come and how they can be applied. So we'll start with one question. It says if for some alpha beta, alpha is less than equal to beta, and alpha plus beta is equal to 8, and sec square tan inverse alpha plus cosec square cot inverse beta is equal to 36. Then alpha square plus beta is equal to what? So this is a question which was asked in this year only, in the January session, in this 2025. So if we try to do this question, so we basically want to find here the values of alpha and beta, and then we will find the answer, alpha square plus beta. So one thing is given, that alpha plus beta is equal to 8. This is one equation between alpha and beta. Between alpha and beta, there should be another equation also, then only we can solve two equations and get two unknown. So another equation is given like this. So here, suppose if we talk about sec square tan inverse alpha, so how should we write it? So what we do, let tan inverse alpha is equal to x. Okay, this is some angle x. So what it means, that tan x is equal to alpha. Now, if you want to find sec of tan inverse alpha, this is what is there. So you are basically talking about sec of x, because x is tan inverse alpha. So therefore, if we draw a triangle, and in that triangle, according to this relation, that tan x is equal to alpha, so this is the angle x, alpha is the perpendicular, and 1 is the base. What will be the hypotenuse? Root over 1 plus alpha square. So sec x will be equal to sec of tan inverse alpha, which is equal to sec x. Sec x is hypotenuse by base. So it will become root over 1 plus alpha square by 1, which is basically root over 1 plus alpha square. So this is what we got is sec of tan inverse alpha. In similar manner, we will also find cosec of cot inverse beta. So now let cot inverse beta is equal to y. So this means that cot of y is equal to beta. Now what we have to find is we have to find cosec of cot inverse beta. So cosec of cot inverse beta will be equal to cosec of y. And again we make a triangle, and in this triangle this angle is y, and the base is beta and perpendicular is 1 because b by p is cot and hypotenuse is 1 plus beta square. So what is cosec y? Hypotenuse by perpendicular. So root over 1 plus beta square by 1, which will be equal to root over 1 plus beta square. So after knowing these two values, what we can do is we can use this in this equation. Sec tan inverse alpha is root over 1 plus alpha square, and there is a square of it. So it will simply mean therefore 1 plus alpha square and cosec square cot inverse beta. So cosec into cosec of cot inverse beta is root over 1 plus beta square. So its square will be 1 plus beta square, square root will vanish. And this is equal to 36. So you see that alpha square plus beta square is equal to 36 minus 2, 34. This is another relation between alpha and beta. Now using this relation and this relation, you have to find alpha beta. So first write till here and try to find alpha beta, then we will discuss it. So I hope you have written till here. Let me slide it down. So now you have this relation alpha square plus beta square equal to 34, and this is given alpha plus beta equal to 8. So how can you find alpha and beta? Can you tell what will be alpha and beta? I'm writing both the equations here. Alpha square plus beta square equal to 34 and alpha plus beta is equal to 8. How to solve and find alpha beta? So it is not so difficult. What we will do, there are many ways. So best way is to just take beta from here, which is 8 minus alpha. So it will become alpha square and beta will become 8 minus alpha. Square of this equal to 34. So what you get is alpha square, and from here also alpha square will come. So it will become 2 alpha square minus 16 alpha it will become, and plus 64. 8 square is 64. 64 minus 34 is 30, plus 30 equal to 0. So this is a quadratic we are getting. 2 we can take common. So it will become alpha square minus 8 alpha plus 15 equal to 0. This will factorize by middle term splitting, x minus 5 into x minus 3 equal to 0. So you are getting two values, 5 and 3. So one of these two is alpha and another is beta. Now, which is alpha and which is beta? It is also important to see that which is alpha and which is beta. So there is a condition which was given earlier. If you see the question, that alpha is less than equal to beta. So a smaller value is alpha and greater value is beta. Therefore, alpha is 3 and beta is equal to 5. And the value which we have to find is alpha square plus beta. So what will be alpha square plus beta? Finally, we can get the answer. So alpha square plus beta is equal to 9 plus 5. The square of 3 is 9, 14. This will be your answer. If you have feeling like you've understood it, then it is okay. If you feel like you have asked something or some step is not clear, so you can definitely ask it. I will make it more clear. Okay. So I think we can move on to the next question. So this was the first question. This was in 2025 January shift. Now we come to another question. The number of real solutions of the equation two sine inverse x plus 3 cos inverse x is equal to 2 pi by 5 is. So how many number of real solutions are there? And this was a question of 2024 April shift. So let us see how we can approach this question. So there is this relation that 2 sine inverse x plus 3 cos inverse x is equal to 2 pi by 5. So there are two different functions. One is sine inverse, another is cos inverse. Is it there a way that we can only write one function? Is there in any such way? Either in sine inverse or in cos inverse? So if you remember, there are few formula which were like this, that sine inverse x plus cos inverse x is equal to pi by 2 always. Sec inverse x plus cosec inverse x is also always pi by 2. Tan inverse x plus cot inverse x is also pi by 2. So if you see these relations, you can do one thing, you can substitute suppose we substitute cos inverse x. Cos inverse x will be pi by 2 minus sine inverse x. And this is equal to 2 pi by 5. So this is what we can do here. Then from here 2 sine inverse x, and here it will be minus 3 sine inverse x. So we'll get minus sine inverse x. And this will become 3 pi by 2 is equal to 2 pi by 5. So sine inverse x I'm taking on another side and writing it like this. Sine inverse x is 3 pi by 2 minus 2 pi by 5. So it will be, after taking LCM, 15 minus 4, 11 pi by 10. So this is sine inverse x. Now sine inverse x is coming out to be 11 pi by 10. Principal values, basically, if you remember principal values, I have in the starting of the class already told you that what are the principal values of 6 inverse trigonometric functions. If you remember, the principal value of sine inverse is minus pi by 2 to pi by 2, minus 90 degree to 90 degree. It can't be more than 90 degree, it can't be less than minus pi by 2. But what is coming over here, if you observe here, it is coming 11 pi by 10, which is actually greater than 180 degree. Pi plus pi by 10. What is this? Pi plus pi by 10. So it is greater than pi by 2. It is not possible to get any value of x for which sine inverse x will be 11 pi by 10. So there is no value, no real value of x for which this is possible. This equation is possible. So they were asking that the number of real solutions of the equation. So what we will say, the number of real solutions are 0. So answer would become 0. Now you can write it down starting from here. This is the final result which we have come to the conclusion. Let us come to another question. The question says for n belonging to natural number, if cot inverse 3 plus cot inverse 4 plus cot inverse 5 plus cot inverse n is equal to pi by 4, then n is equal to. This question has come in 2024, yeah, April shift. First you try it, then we'll discuss. I can give you a hint. Try to change cot inverse into tan inverse. Don't keep it as cot inverse, because generally we remember the formula of tan inverse, but we don't remember the formula of cot inverse. So better to change them in tan inverse. How will you do that? That you have to think. There is a formula. So what you can do here, I'm not explaining every step. I'm just giving you some initial steps first. There is a formula, right? There is a formula which says if you remember, sine inverse x is equal to cosec inverse 1 by x. Okay. And both are having same principal value, only that cosec inverse does not include uh, 0. So both is having minus pi by 2 to pi by 2. This is a relation. And then we have a relation that cos inverse x is equal to sec inverse 1 by x. And they also have same principal value 0 to pi. Sec inverse does not include 0 in pi by 2 in between. So that we will not take into consideration. And when we come to cot inverse x, there is two possibilities. It could be equal to tan inverse 1 by x if x is a positive number, and tan in pi plus tan inverse 1 by x if x is a negative number. Okay. So tan inverse 1 by x will give you a negative value. You will add it with pi, and then you will get some value between 0 to pi. That will be cot inverse x. Why this is the reason? Because tan inverse is having principal value minus pi by 2 to pi by 2, and cot inverse is having principal value 0 to pi. They have different principal value regions. So these formula which we need to remember. Now here the formula which we have to apply is, first of all, as I'm saying, that change cot inverse into tan inverse. So if we do that, the question can be written as, since you can see here that cot inverse 3 is there, 3 is a positive number, 4 is a positive number, 5 is a positive number, n is also a natural number, positive number. So all of these are positive. So we should apply this result, x positive. So we can write this as tan inverse 1 by 3 plus tan inverse 1 by 4 plus tan inverse 1 by 5 plus tan inverse 1 by n is equal to what it was, pi by 4. So that question we change it like this. Why we are changing? Because we generally remember the formula of tan inverse x plus tan inverse y. And what is that formula? That is again a very important formula, that tan inverse x plus tan inverse y is equal to tan inverse x plus y by 1 minus xy if xy are positive and x multiplied with y is less than 1. If this is not the case, then it will be pi plus tan inverse x plus y by 1 minus xy if xy is positive and x into y is greater than 1. So this formula is also very important formula, and generally questions you will see have been coming from this formula. So here you can apply this formula. So first write this and then try to apply this formula. First write this. Now after writing this is our question now, and you have to use this formula. So as you can see here, this x into y, all these are positive, 1 by 3, 1 by 4, 1 by 5, 1 by n, because n is also natural number. So this condition is getting satisfied. X is also positive, y is also positive. X into y, suppose we take 1 by 3 and 1 by 4. So what is their product? 1 by 12, which is less than 1. So if we apply this result here, this above 1, because xy is less than 1 here. So tan inverse 1 by 3 plus 1 by 4 upon 1 minus 1 by 3 into 1 by 4. We can write it like this. And then tan inverse 1 by 5. And then tan inverse 1 by n. And this is equal to pi by 4. Now if we calculate this tan inverse, this will become 7 by 12 and this will become 11 by 12. So it will become, after calculation, 7 by 11 plus tan inverse 1 by 5 plus tan inverse 1 by n is equal to pi by 4. Again, let us check 7 by 11 and 5. If we want to check 7 by 11 into 5, 7 by 11 into 1 by 5, sorry. So it is 7 by 55 is still once it is less than 1. So here also this above result will apply, tan inverse x plus y by 1 minus xy. So we'll write tan inverse x plus y, 7 by 11 plus 1 by 5 by 1 minus 7 by 11 into 1 by 5 plus tan inverse 1 by n is equal to pi by 4. So when you simplify this, it will become 35 plus 11, 46 upon 55, and here it will become 55 minus 7. So 55 minus 7 is 48. So this is becoming tan inverse 46 by 48 plus tan inverse 1 by n is equal to pi by 4. Now this is tan inverse 46 by 48 is 23 by 24 plus tan inverse 1 by n is equal to pi by 4. So we write tan inverse 1 by n is equal to pi by 4 minus tan inverse 23 by 24. Now we do further. First write till here. We have started writing it from here. First write till here. Then write this also till here. Now from here, can you find n? Just try. Let me give you a hint. Take tan both the sides. If you take tan both the sides and then proceed, will you get the value of n? In between, you will apply one formula of trigonometry, that is tan of a minus b. Okay, so let us see. There is nothing more now, not much now. Tan of tan inverse 1 by n, we are writing it here, is equal to tan of pi by 4 minus tan inverse of 23 by 24. So this is tan of pi by 4, that is tan A, minus tan B, that is tan of tan inverse of 23. This is 23 by 24. And tan of pi by 4, when you will apply tan over all of this, then it will become tan of pi by 4 minus tan of tan inverse tan of tan inverse 23 by 24 by 1 plus tan of pi by 4 into tan of tan inverse of 23 by 24. This is the same formula tan A minus B, which we do in trigonometry in class 11. So first of all, what will happen here? This tan of tan inverse 1 by n will become simply 1 by n. And here in this one, tan pi by 4 is 1, and tan of tan inverse 23 by 24, tan and tan inverse will cancel, and this will be 23 by 24. Okay, 23 by 24 is a value, and in the denominator what we get 1 plus, and tan pi by 4 is also 1 here, so this is 23 by 24. So we get 1 by n is equal to, we take LCM, so it will become 1 by 24, and here it will become 47 by 24. So n is coming out to be 47. This will be our answer. Finally, write this down. Now we come to another question. So all the formula which we are getting in between, like this formula, this formula, this formula here. So all of these formula you have to, this method actually, this is a very important method to find another trigonometric function if some other inverse trigonometric function is given. So this all we are very important part, and you have to remember them. That will be helpful. So next question we come. For x belonging to -1, 1, the number of solutions of the equation sin inverse x is equal to 2 tan inverse x is equal to. So here again, let me give you one hint that what you can do is this 2 tan inverse x, right? This is sin inverse x is equal to 2 tan inverse x, and x is between -1 and 1, where -1 is not included, but 1 is included. So First task is to change this 2 tan inverse x in the form of sine inverse. How we can do that? That you have to think. You can proceed here like this also, as we have done in first question, with a little change, that let tan inverse x is equal to theta. We are concentrating on the right hand side. Okay. This means that tan theta is equal to x. Now on the right hand side, 2 tan inverse x is given. So 2 tan inverse x means 2 theta. So if we talk about finding sine 2 theta first, so this is 2 tan theta by 1 plus tan square theta. If you remember this formula, this simple trigonometric formula, so it will become 2 tan theta is x and this is 1 plus x square here. So sine 2 theta is 2x by 1 plus x square, which means that theta is equal to, now you can say that this 2 theta is equal to sine inverse we take here, sine inverse 2x by 1 plus x square. Okay. And since we know that x is between -1 to 1, it is very important to see this constraint also. X is between -1 to 1. What it means? It means that tan inverse x, which is theta, is between minus pi by 4 to pi by 4. Okay. This is what it means. Theta is tan inverse x, which means if you talk about this 2 theta, so 2 theta is between minus pi by 2 to pi by 2, which is the principal value region of sine. So we can take this sine on the right hand side and take it as sine inverse. If this condition was not there, then you will have to make many cases. So this condition was very important. So knowingly you may not be applying it, but you should know that this condition will help you, how it is helping you. So what it becomes is now that sine inverse, this 2 tan inverse x is basically 2 theta. So therefore sine inverse x is equal to 2 theta is becoming sine inverse 2x by 1 plus x square. So this is now the reduced equation. This you have to solve now. Now it is not much to do here. As you can see also, sine inverse x is becoming equal to sine inverse 2x by 1 plus x square. So you can remove sine both the side, sine inverse from both the side, or you say you take sine both the sides. So this will become x is equal to 2x by 1 plus x square. So we take multiply here, x into 1 plus x square is equal to 2x, and don't cancel x because that will also give you a root. So x into 1 plus x square minus 2x is equal to 0. You take x common, so it will be 1 plus x square minus 1 is equal to 0. X square, this is 2x, no, right? X into 1 plus x square, 2x, okay? This is minus 2, sorry. This is not minus 1, this is minus 2. X into 1 plus x square minus 2. 1 plus x square minus 2. So x into x square minus 1 is equal to 0. So the values of x which we are getting is x equal to 0, and from x square minus 1, plus 1 and minus 1. But in the question, it is given that minus 1 is not included. They could have taken minus 1 included also, but there is one more purpose of taking not minus 1 included, that a student should not uh, watch it clearly, do missing seeing it clearly, and they just write that there are 3 solutions. But if you see it clearly, it is mentioned, that is meticulously you have to observe that minus 1 is not included. So if any one value is coming minus 1, you can't take it as the answer because this is not included in the question. In condition it is okay, you can take minus 1, but in the question it is not there. So x is 0 and 1 only which are acceptable values. So since x belonging to minus 1 comma 1, therefore x is equal to 0 comma 1 are acceptable values. So they are saying that how many number of solutions, I think, number of solutions. So number of solutions is equal to, now we come to the next question. This was fourth, no? We come to fifth question. If S is a set which is having X as an element, X belong to real number, such that sine inverse X plus 1 upon square root of X square plus 2X plus 2 and then minus sine inverse x upon root over x square plus 1 is equal to pi by 4. Then sigma x belonging to S. So whatever the elements in S are, we are taking all those elements, and then we are taking the value sine of x square plus x plus 5, okay, into pi by 2, bracket closed, minus cos inverse, cos, not cos inverse, minus cos minus cos x square plus x plus 5, it is also same here, into pi, and then finally the bracket gets closed. This is equal to, okay, so the question seems to be difficult, but it is not difficult, okay. If you think in the right direction, it will not be so difficult, since it is looking like complex, but it is not so complex. So first give it a try, then I will discuss. First find the elements which are in S. What it means? First find the solutions of this equation. This equation is given. Solve this equation, find the values of x which are coming. Let me give you a hint. What we can do here is, we let alpha is equal to this sine inverse x plus 1 by square root of x square plus 2x plus 2. Let us suppose that is alpha, and beta is equal to sine inverse of x by root over x square plus 1. The second one is beta. Now you have to proceed by taking sine both the sides. Before that, you should find cos inverse also of both the values. So first do this, then I will tell you. So what you do here now is, this is alpha which you have taken, okay? So you can say that sine of alpha is equal to x plus 1 upon, and this value here is actually x plus 1 whole square plus 1. Okay, if you see this, x square plus 2x plus 1 plus 1, which is 2. Now we have done this in the first question also. Suppose if this is the angle alpha, so sine alpha is perpendicular, this is the perpendicular, and hypotenuse, this is root over x plus 1 whole square plus 1. So clearly the base is 1. Then only hypotenuse is root over length square plus height square plus base square. So from here, if you want to find cos alpha, you can say that it is base, which is 1, by hypotenuse, which is x plus 1 whole square plus 1. Similarly here, you can write sine beta, and this is equal to x by root over x square plus 1. And again we draw triangle, right angle triangle. This is beta. Sine beta is perpendicular, so x is perpendicular and hypotenuse is root over x square plus 1. So what is the base? It is 1. So here we can say that cos beta is equal to base is 1 and hypotenuse is root over x square plus 1. So first write till here. Okay, then take in this equation both sides sine. It will become basically sine of this is alpha and this is beta. So if you will take sine both the sides, this is simply sine of alpha minus beta is equal to sine of pi by 4. Sine of pi by 4, we know it is 1 by root 2. So here this is equation is simply sine of alpha minus beta is sine pi by 4. Then expand this sine alpha minus beta by trigonometric formula. That is the formula of sine A minus B. We remember now, it is sine alpha cos beta minus cos alpha sine beta, and sine pi by 4 is 1 by root. Now let us see what are these values. Sine alpha. Sine alpha is x plus 1 by, this is x plus 1 by root over x square plus x plus 2. What is cos beta? Cos beta is 1 by root over x square plus 1. Minus cos alpha. Cos alpha is again 1 by root over x square plus x plus 2. I'm writing it like this. And sine beta is x by root over x square plus 1. This is equal to 1 by root 2. Now we have to simply solve this equation, and now it is becoming, if you see the denominator, both are having the same denominator, root over x square plus x plus 2 into root over x square plus 1. Numerator here is x plus 1, and here it will become minus x. This is 1 by root 2. So x and x will cancel, and we cross multiply, so it will become root 2 is equal to root over x square plus x plus 2 into root over x square plus 1. Now we square both the sides, so this is 2 is equal to x square plus x plus 2 into x square plus 1. Okay. Now you have to find the value of x. So what you can do here is, you can do some manipulation here, like if you multiply x square into x square will be x to the power 4, and then you will get x square plus x cube. So x cube will be there, and x square will be there, and 2x square will be there. 2x square plus x square will become uh, 3x square, and then there will be x, and then there will be 2. So this is what we are getting here. This 2 and this 2 cancels. We take x common, so it will become x cube plus x square plus 3x plus 1 equal to 0. Now we have to find the solution to this. Okay, one solution is x equal to 0. What it is saying? Okay, the values of x. What are those values of x? Okay, so one value of x is coming 0. Okay, that is fine. Another is x cube plus x square plus 3x plus 1 equal to 0. Now, how can we solve this? Little bit hit and trial will be done here because it is a cubic. So if you see 1 here, that will not serve the purpose. Minus 1 if you put, then also it will not help. 2 minus 2 if we put, minus 8, 4, minus 8, 4 and minus 6 plus 1, it is not going to help. I think calculation is correct now, because it should not be such a type of equation now. X plus 1 minus x, and this is this. So root 2 is equal to this, that is fine. 2 is equal to this, that is also fine. So x to the power 4, then x square, and this will give you 2x square, this will give you 1x square, 3x square, and then we have x cube, then we have x, then we have 2. Okay, 2 cancels, x cube plus x square plus 3x plus 1 equal to 0. So if we take, suppose there is a way of solving these type of polynomial equations. If suppose we have all the coefficients as integers. Okay, so all the coefficients here are integers, and the factor here is, if there is a rational root, then it should be 1 or minus 1. So then 1 or minus 1 should satisfy this. Let me see, only this is the solution or some else is also the solution. Let me check for the answer for this one. So the answer is one more term is there. So let me check the calculation part if there is anything we have missed. This was x plus 1 and this, and then we have this as perpendicular and this as hypotenuse, base by hypotenuse, it is fine. This is perpendicular and hypotenuse, and this is base by hypotenuse, it is also fine. Then it is sine of alpha minus beta. I think this is the question. It is sine of alpha minus beta. Yeah. So it is sine pi by 4. So we take it as a 1 root t sine alpha cos beta we take. So x plus 1 by this term we will get fine. And cos alpha sine beta is x by this we are getting, okay, is equal to 1 by root 2. So when we take the LCM, it will be x plus 1 minus x, okay. This is 1 by root 2. So x square plus x plus 2 into x square plus 1 is equal to root 2 is equal to 2. This is fine. Let me write this again. Maybe something would be there which we were missing. Let me write this again by expanding it properly. So this is 2 equal to x to the power 4 plus x cube plus 2x square. When we multiply with x square, then x square plus x plus 2. So it will become x to the power 4 and then x cube and then 3x square. Then we have x and then we have 2. This is 2. It gets cancelled. So what we get is this term. Here we take x common. So x cube plus x square plus 3x plus 1 is equal to 0. This is what we are getting earlier also. So from here we are getting x equal to 0. Then in that case, this is the only answer which we are getting. So I think their answer may be different. We have to take x is equal to 0. Okay, we take only one value, x is equal to 0. So for that x is equal to 0, we have to calculate this. So it is sine of x0. So this is 0, this is 0, sine of 5 pi by 2. So it is therefore sine of 5 pi by 2. And then we have here also x square and x are 0. So cos of 5 pi minus cos of 5 pi. Sine 5 pi by 2 is actually sine of 2 pi plus pi by 2, right? And cos 5 pi is 4 pi plus pi. Now we know that every 2 pi it repeats itself. So it will simply sine pi by 2. And this will be simply cos pi. So sine pi by 2 1 and cos pi is minus 1. So it is 1 plus 1 which is equal to 2. So the answer would be 2. They have given answer as 4 and they have got two values. But another value is not coming here. So they might have done some mistake somewhere. So you can now write it down starting from here only. Okay. You can write this now. So after this, let us see one more question. Then we can conclude the class. We have almost tried all type of questions so that we can have an understanding. Now we have a question on domain. So these type of questions are not too difficult. Okay, domain questions, you can, if you know the principal value concept. So it says that if x is equal to sec inverse 2x by 5x plus 3. Okay, and you have to find its domain basically. Okay, this is a question which has come in 2023. Question is asked in a different manner, but basically they want to find the domain. So how do we find the domain for sec inverse of any value? That should, what is the domain for that? So if you remember, sec x sec x give a value which is either greater than equal to 1 or less than equal to minus 1. So sec inverse will take a value which is greater than equal to 1 or less than equal to minus 1, just like in cos inverse. In cos inverse the value is between 1 and minus 1. For sec inverse, it is reciprocal of cos. Sec is reciprocal of cos. So it is greater than equal to 1 or less than equal to 1, minus 1. So we have condition that this 2x by 5x plus 3 is either greater than equal to 1 or 2x by 5x plus 3 is less than equal to minus 1. So this we have to solve now. So you remember that wavy curve method we do, we take this minus 1 on the left side is greater than equal to 0. We don't cross multiply, okay? We don't know the sign, na? 5x plus 3 plus 1 is less than equal to 0. So it will be 2x minus 5x, that will be minus 3x minus 3 upon 5x plus 3 greater than equal to 0. And here it will be 2x plus 5x, that will become 7x plus 3 by 5x plus 3 greater than less than equal to 0. So what you can take, minus sign you can take common, 3 also, so it will become x plus 1. And if you take that minus sign on the right hand side, it will become less than equal to 0. The sign will reverse, inequality will reverse. 7x plus 3 by 5x plus 3 less than equal to 1. The point is minus 1 is a 0 and minus 3 by 5 is a pole. Okay. So minus 1 is here and minus 3 by 5 is here. So this is positive, this is negative, this is positive. So what value we can take? We can take x belonging to minus 1, which can be included. Minus 3 by 5 is not included because it is, then it will, denominator will become 0. So we won't include that. Here it is minus 3 by 7 and minus 3 by 5. So minus 3 by 5 again we can't take, include, and minus 3 by 7 will be somewhere here, suppose. So this is again plus minus plus. So x belongs to minus 3 by 5 to minus 3 by 7. This is closed interval. So if we see that what is the final answer, it is the union of x belonging to -1 comma -3/5 union -3/5 comma -3/7. Or you can also write it like this, that it is -1 to -3/7 except -3/5. You can write it like that also. So write it down starting from here. Write this part also. So principal value, you should remember, let me write it here only. Principal values, what are those? For sine inverse x and cos inverse x, it is -pi/2. Oh, sorry, sine inverse x, it is 1 second. Yeah, sine inverse x belongs to -pi/2 to pi/2. Okay, and x is between 1 and -1. Cos inverse x belongs to 0 to pi. This is the principal value. And x belongs to 1 to -1. Then we come to tan inverse. Tan inverse x belongs to -pi/2 to pi/2 open interval, and x belongs to real number. Then we come to cot inverse x. Cot inverse x belongs to 0 to pi open interval, x belongs to real number. Then we come to sec inverse x. Sec inverse x belong to just as in cos inverse, but except it will not include one value, which is pi/2. And here x is either greater than equal to 1 or x is less than equal to -1. And cosec inverse x, here it will become again -pi/2 to pi/2, like in sine, except one value 0 it can't take. Here also x greater than equal to 1 or x is less than equal to -1. So this you should remember. This is a very important concept. So write this also. I hope you have written till here. Then write that also. write this result. This is also a result to be remembered. So we will meet again in the next class with another topic, and we'll discuss that also. So I hope you will revise all the content which has been taught in this class and you will practice questions.